For centuries, humanity has gazed at the stars, dreaming of voyages beyond Earth. We have sent rockets to the moon, probes to the outer planets, and even glimpsed the vast emptiness beyond our solar system. But there is one thing that has always held us back: fuel. It is heavy, expensive, and ultimately limits our ability to travel far and fast. What if there was another way? Every space mission begins with fire and thunder. Rockets burn fuel at unimaginable rates, with the Saturn V moon rocket consuming 20 tons of fuel per second during launch. The cost? Astronomical. The Apollo program, adjusted for inflation, cost over $150 billion. Today, NASA's Artemis program aims to return humans to the moon, but a single launch can cost up to $4 billion, and once we get there, the problem isn't solved. To escape the moon's gravity, we still need more fuel. Every extra kilogram launched requires exponentially more energy. This is why space travel remains the privilege of robotic probes and a few lucky astronauts. But what if we could escape this limitation? Scientists around the world have explored propulsion methods that require little to no fuel. Some are rooted in solid physics, while others challenge everything we know about reality. The first and most realistic alternative is solar sails. Unlike rockets, which carry fuel, solar sails use light pressure from the sun to propel spacecraft. This isn't science fiction. Japan's Icaros mission successfully used this method in 2010. And NASA's new ACS-3 solar sail is testing advanced designs right now. A solar sail doesn't burn fuel. Instead, it is pushed by photons, tiny particles of light. While the force is small, it accumulates over time, allowing a spacecraft to reach speeds far beyond what chemical rockets can achieve. Given enough time, solar sails could take us to other stars. But what about methods that go beyond known physics? Enter the EmDrive, a controversial propulsion system that claims to generate thrust without expelling any mass. According to traditional physics, this shouldn't work. And yet, in 2016, NASA's EagleWorks lab reported measuring small amounts of thrust in their experiments. The EmDrive supposedly works by bouncing microwaves inside a chamber, somehow generating motion. If true, it could revolutionize space travel. But there's a problem. Multiple follow-up experiments have failed to replicate the results, suggesting the effect was due to experimental errors. In 2019, a NASA engineer named David Burns proposed something even stranger: the Helical Engine. This device, if real, would create thrust without propellant by accelerating ions in a loop path, effectively manipulating mass and momentum inside the system. The idea is based on the principle of mass change at relativistic speeds. But most physicists remain skeptical. Could this be the answer to interstellar travel, or is it just another impossible dream? Beyond fuel-free travel, there is another idea, one that breaks the laws of physics as we know them. The Alcubierre warp drive proposes a method to bend space-time, creating a warp bubble that moves faster than light. This concept, once pure science fiction, is now being seriously explored by theoretical physicists. If possible, such a drive would allow us to cross the galaxy in weeks instead of thousands of years. But is it practical? The energy required is currently beyond our reach, and some argue it would require exotic matter that may not even exist. So is fuel-free space travel possible? Right now, solar sails are our best bet. The EmDrive and Helical Engine remain unproven, while the warp drive is a dream of the distant future. But history has shown us that the impossible can become reality. The mystery of how we will explore the stars remains open. Perhaps one day we will crack the code and leave rockets behind forever. The universe is waiting. The question is, how will we get there?